We continue with part 4 of chapter 2 with section 2.6, understanding and predicting the effects of changing market conditions. We can use supply and demand curves to analyze and predict the effects of changing market conditions by using numbers. In order to do so, we must learn to fit the linear supply and demand curves to data. Suppose you have the equilibrium price P star and equilibrium quantity Q star. You also have another set of numbers, the price elasticity of supply and the price elasticity of demand. We can then use these values to determine the parameters of the supply and the demand curve. With the linear supply and demand curves derived, we can thus use it to analyze the changes in the market affecting price and quantity. So to recap figure 2.2, we have our supply curve in the linear form, where Q is the subject of the formula, and we have our parameters C and D, and we have our linear demand curve with our parameters A and B. We are going to use the following two steps to find these parameters. And in terms of the sets of information we will be using, we will use a value for P star and Q star that will be given as the equilibrium price and quantity, as well as our price elasticity of demand and price elasticity of supply. We will begin with the linear demand and supply curve from figure 2.20. So the demand curve is given as Q is equal to A minus BP. That will be equation 2.5a. And supply is given as Q is equal to C plus DP. And that will be equation 2.5b. Now, to find the parameters A, B, C, and D, we have two steps that we need to follow. Step 1, we know that the price elasticity can be written as our price elasticity is equal to the ratio of the price to the quantity, so at a particular point, multiplied by a change in the quantity demanded or quantity supplied over a small change in price. And from 2.5a, we can see that the change in Q over the change in P is given by minus B in 2.5a. And for supply, the change in Q over the change in P is given by plus D in equation 2.5b. So these values are now substituted in the respective elasticity formulas. So you can see that all that we've done in this formula is we've modified it such that minus B for the demand represents that change in Q over change in P, and for the supply, D represents that change in Q over change in P, and the values P star and Q star represent the equilibrium price and quantity at a point. Since we have these two sets of values, we can rearrange it to solve for minus B and D. So essentially we will, in our first step, rearrange these two equations such that minus B is on the left-hand side and D is on the left-hand side, given that we will have the information for our elasticities, coefficients, as well as our equilibrium price and quantity. In step 2, since we now have minus B and D, we can substitute these values as well as P star and Q star to solve for the unknown constant A, that is for the linear demand function. and C if we were looking at the linear supply function. Thus, our equation for 2.5a can be rewritten such that A is the subject of the formula, and since we have our equilibrium price and quantity, and we were able to determine our parameter minus B, we can now solve for A. And once we have those unknowns, we have in fact derived our linear demand curve, and similarly, you'll be able to derive your linear supply curve. So although we have written supply and demand so that they only depend on price P, we know that demand could depend on other variables such as income as well as P. So here in equation 2.7, it is written with not only P being a particular variable, but I here is an index of aggregate income. So let's work through an example of how to determine our linear demand and supply curve. Given certain information, let's begin with our equations for supply, demand, and elasticity. So we have our general form of demand, supply, and elasticity. For demand, that is Q is equal to A minus BP. And for supply, that is Q is equal to C plus dP. And our general formula for elasticity is the ratio of P to Q multiplied by the change in Q over the change in P. And we need to calculate the parameters A, B, C, and D. Now, note that when you graph demand and supply, you have price on the vertical axis and quantity on the horizontal axis. Thus, the slope is in fact your change in price over your change in quantity graphically. However, your linear demand curve is given as Q is equal to A minus BP. Thus, here minus B represents the inverse of the slope. So that is in fact the change in Q over the change in P. And the same rationale can be applied for D over here. So the slope of the demand curve here for minus B is equal to our change in Q over change in P. And the slope of the supply curve above also equals change in Q over change in P, and that is D. And here we have our general formula for our elasticity. So thus for our price elasticity of demand, we can now substitute minus B for this portion, change in Q over change in P, multiplied by the equilibrium, the ratio of the equilibrium price and quantity, that is that portion at the point over there. And then for our price elasticity of supply, we can substitute D for this portion, changing Q over changing P, multiplied by the ratio of our equilibrium price to quantity, which is that portion of the formula over there. So we have our starting point. So using P star and Q star and the elasticities, we can solve for our B and C, right? So our price elasticity of supply is equal to D multiplied by P star over Q star. And we are going to be assumed that we have been given this particular information. So let's assume that we were given a price elasticity of supply coefficient of 1.6. D is one of the parameters we are solving for. And let's assume that we were given an equilibrium price of 0.75 and an equilibrium quantity Q star of 7.5. Thus, by rearranging, you can solve for D, and D is equal to 16. Right, so now we have D. Now we need to solve for C, and that can be done by a simple substitution again. We can substitute 16 for D as well as our equilibrium quantity, which we saw was 7.5, and our equilibrium price, P star, which we saw was 0.75, and our only unknown now is this parameter C. So by rearranging, making C the subject of the formula, we can determine that it is minus 4.5. So thus far, we've got our two parameters for our supply curve, and those two parameters are C and D. Now let's do the same process for our demand curve. So using the values of 0.75 as our equilibrium price and 7.5 as our equilibrium quantity, we are also going to assume that we have been given a price, an elasticity of demand coefficient of 0 minus 0.8. We know that it would be negative because it relates to demand. So therefore, we can solve for minus B. That is our first parameter we need to solve for. Given our elasticity coefficient that we've been given of minus 0.8 and our equilibrium price and quantity. Thus, our only unknown is minus B in this formula, and B is thus equal to 8. So now we have the following information for our next step. Step 2, we have our value for our quantity. We have B as well as P. So by substituting our equilibrium quantity of 7.5, our parameter B is equal to 8 and price is equal to 0.75. Our only unknown now in step 2, A, is going to be equal to, by rearranging and solving for A is equal to 13.5. Thus, we have all four parameters, A, B, C, and D, for our demand and supply curves. So what are we left with? Well, we have our equations just by following those two simple steps and fitting the data. So I would like you to do a couple of examples in the class exercises that I will be uploading. So if we were to, just as a check, if we were to equate our demand and supply curves to determine the equilibrium price and quantity, we would find that Q is equal to 7.5 and P is equal to 0.75. So the next couple of slides, from slides 44 to 49, present further applied examples examining the behavior of copper prices and world oil markets as a second example. Please work to these to strengthen your understanding. That's slides 44 to 49. I'm just going to resume with the final section, 2.7. Government intervention in regulating markets is common in many a country. In Chapter 9, the effects of these interventions will be discussed. For now, let's review the effects of price controls. In Figure 2.25, the initial equilibrium before any government intervention occurs with the price P0 and quantity Q0. That is the initial equilibrium before any government intervention. If government decides that the price P0 is too high, it can regulate the price to be no higher than P max, a maximum price or price ceiling. As a result, the quantity supplied will fall to Q1 and consumers will demand more and the quantity demanded will increase to Q2. Thus, there is an excess demand or market shortage given by the difference of Q2 minus Q1. It is important to note that some consumers gain, but others are rationed out. Producers lose, and some may leave the industry. The gains and losses are quantitatively and qualitatively evaluated in Chapter 9. You should similarly be able to evaluate a scenario where there is a minimum price, Pmin, which would be an example of a price floor. Slides 52, 51, and 52 just present further examples on price controls and natural gas shortages. Please work through these to further support your understanding. And that concludes chapter